Hi, my name is Dirk van der Merwe, and this is our second online session for our chapter on linear equations. So today we're going to look at how to solve systems of linear equations using some different methods. The first one we're going to look at is substitution. So let's say we have the following two linear equations and we'd like to solve them using substitution. The first thing we're going to need to do is change the subject in one of the equations to either x or y. We can pick the equation where it's going to be the easiest. So changing the subject basically means making either x or y the answer of the equation. So if I take my first equation, I can change its subject to x by moving that negative y over to the left-hand side. So then my equation is going to look something like the following. Minus 5 plus y should then be equal to x. Then the next thing I'm going to do is I'm going to substitute this newfound answer to x, which is minus 5 plus y. Because we said that is equal to x, we're going to substitute that into our other equation. So doing that is going to give me the following equation. Y minus 1 is equal to 2, and then instead of x, we're going to put the new value of x we found, which is minus 5 plus y. So then we can solve this equation. We can find the value of y because there's only one variable in this equation, so we can actually find a definitive value for y. So doing that, we're going to start with our equation, which is y minus 1 is equal to 2 times, then in brackets, minus 5 plus y. So multiplying 2 into the bracket is going to give me minus 10 plus 2y. So then I can move the y on the left-hand side over to the right-hand side. That's going to give me minus 1 is equal to minus 10 plus y. And then I can move a minus 10 over to the left-hand side, which is going to give me the answer to y, which is 9. So then the next thing I can do is I can substitute the value of y found in step 3 into one of the equations, any one of the two equations we started with. So these were the two equations we started with. So let's say we're going to substitute the value of y, which we found earlier, into the first equation. We're basically going to get minus 5 is equal to x minus 9, because we know y is equal to 9, and that means x is going to be equal to 4. So now we have found both the value of x and y, and that would then be the solution to the system of linear equations. These two coordinates, where x is equal to 4, y is going to be equal to 9. So to wrap up, the steps we took in order to solve a system of linear equations using substitution is we changed the subject in one of the equations to x, but it could have been y as well. We substituted the value found in step 1 into the other equation. So we solved y, and then we substituted the value of y into any one of the two equations we started with to find x. So next we're going to look at how to solve a system of linear equations using elimination. So let's say we start with the following two equations. First, we need to make sure that x and y variables are in the same positions in both equations. Basically, that means they need to be on the same side of the equation. So since that is not the case, we're going to have to change our first equation a little bit. So I'm going to move y over to the left-hand side and positive 25 over to the right-hand side. So that's going to give me the following equation. Now, again, considering the two equations we have, we're going to try and eliminate one of the variables from our system, from the two equations. So that's either going to be x or y. So I'm going to decide that I want to remove y from these two equations. So in order to do that, I'm going to multiply either the top equation or the bottom equation with a value. It doesn't need to be the same value. You can multiply your two equations with different values, or you can just multiply one of the equations. The end goal is that we get the same numeric value for both equations, but with different signs. So that means we want to have the same numeric value for y in both equations, but with different signs. So I'm going to multiply my top equation with 2. So I'm going to take each term in my equation and multiply it with 2. So that's going to give me 16x minus 6y equal to 50. So now we achieved our goal. In both equations, y now has the same numeric value, but it has different signs. Now, the reason we want to do this is we're going to end up adding these two equations together. So we're going to say 16x minus 6y equal to 50 plus 5x plus 6y equal to 8. And basically, the way we're going to add up the two equations is we're just going to add up all the x values, add up all the y values, and add up all the numeric values. So 16x plus 5x is going to be 21x, minus 6y plus 6y, they're going to cancel out, and minus 50 plus 8 is minus 42. So then we can get x alone by dividing by 21 on both sides. And that's basically going to solve my linear equation. So we can say that x is going to be equal to minus 2. Then from here, we're going to approach the problem the same way we did with substitution, because if we know the value of x, we can substitute that into any one of the two equations we started with to find the value of y. So that's what we're going to do next. We're going to take our two equations, decide which one we want to substitute x into. I'm going to take the first equation, but it doesn't really matter which one you choose. And if I substitute x with the value, or if I substitute x with a value I found earlier, which is -2, I can create the following equation. 8 times minus 2 plus 25 is equal to 3y. So that means minus 16 plus 25 is equal to 3y. So 9 is equal to 3y, meaning 3 is equal to y. So now I found both x and y, and that then is the solution to this system of linear equations, where x is equal to minus 2, y is going to be equal to 3. And here are the steps we took. First, we have to make sure that the x and y variables are in the same positions. When we're going to pick a variable we'd like to eliminate, either x or y, then we're going to multiply the first equation or the second equation or both equations with values, so that the variable we decided to eliminate is going to be the same in both equations, but with different signs. Then we're going to add the equations together. That should eliminate one of the variables then. Then we can solve the other variable, and once we have an answer for either x or y, we can substitute that into one of our original equations, giving me the other missing variable's value. Then the last method we're going to look at to solve a system of linear equations are determinants. So let's say we have the following two linear equations. So in both equations, we need to have the numeric value as the subject. Now, in the second equation, the numeric value is the subject, but that's not true in the first equation. So we're going to have to move y over to the left-hand side and that minus 7 over to the right-hand side. So then my two equations are going to look like this. And the next thing I'm going to do is I'm going to create 3 2x2 boxes called matrices or determinant. And now these boxes will be labeled d, dx, and dy. And in the d box, we're going to put the x and the y values. In the dx box, we're going to put the numeric values and the y values. And in the dy box, we're going to put the x values and the numeric values. Now I'll show you what this is going to look like. So we're going to have our 3 little boxes, 2x2 boxes, called d, dx, and dy. And then we can populate them. Now remember, we said in the first box, we're going to put the x and the y values. So in the first column, we're going to put the numeric values associated with the x values. And in the second column of the first box, we're going to put the numeric values associated with the y values. Now, moving on to our dx box, we're going to put the numeric values and the y values. So the numeric values in each equation was 7 and minus 2, so that goes into the first column. And the y values, or the numeric values associated with the y values, were minus 1 and 4, so that goes into the second column. And then for our dy box, we're going to put the x values and the numeric values, which were 3 and -5, and 7 and minus 2. Now, note that the order in which these things appear in each of these boxes are actually important. If you start switching them around, you're going to get incorrect answers. So the next thing we're going to do is we're going to cross multiply the values from each of the boxes and subtract the answers. So we're going to be multiplying the value in the top left corner with the value in the bottom right corner, and the same for the values in the bottom left corner with the values in the top right corner. Like I say, we're going to multiply these values and then we're going to subtract them from one another. So basically, it's going to look something like this. We're going to say 3 times 4 minus 5 times minus 1. And in the dx box, we're going to say 7 times 4 minus 2 times minus 1. And in the dy box, we're going to say 3 times minus 2 minus 5 times 7. So if we do that, we're going to get the following answers. So we know that the d box is equal to 7, the dx box is equal to 26, and the dy box is going to be equal to 29. And then we can find the values of x and y by creating a fraction. We're going to say dx over d should be equal to x, and dy over d should be equal to y. So dx over d is going to be 26 over 7, and dy over d is going to be 29 over 7. And that then is going to be my solution to the system of linear equations. X is going to be 26 over 7, and y is going to be 29 over 7. So using this determinant methods, we can actually solve pretty complex problems, which includes fractions, by only using multiplication and subtraction. So quickly to recap on the steps we took, for both equations, we need to make sure that we have a numeric value as the subject. Then we're going to create our little 2x2 boxes called the d box, the dx box, and the dy box. Now take note that the order in which you populate these boxes are important. Then we're going to cross multiply the values and subtract the answers. And then we're going to find x by taking the answer of a dx box and using it as the numerator and the value of a d box as the denominator. And we're going to do the same thing for y. We're going to take the values or the answer we got for the dy box and use it as a numerator, and then the answer we got for the d box as the denominator. And that then should give me my answer to my system of linear equations, or the two coordinates, which specifies the answer. So then we also have some exercises. The first exercise, or the first two exercises, is where you have some system, or you have to solve some systems of linear equations using substitution. Then the next two questions, you have to solve some systems of linear equations using elimination. And the next two questions, again, you have to solve systems of linear equations using determinants. So thanks for joining, and see you next time.